In the previous lesson, we saw how to access different properties inside the DOM. At that time, I mentioned that using document.all or selecting elements by index is never the right way. Now, we will explore how to properly select elements and what methods the browser provides for this. Let's start with getElementById. From the name itself, it's clear that if we assign an ID to an element, we can capture it using this method. For example, suppose there's an input element with the ID amount. If we write document.getElementById in the bracket amount, we will immediately get a reference to that input element. That means with the reference of that input element, we can fetch its value, update it with a new one, change its style, and perform many other operations. If we open our index.html file, we will notice plenty of IDs and classes. Why do we use these IDs and classes? Normally, we use them in CSS to style specific elements. But those same ID and class attributes can also be used inside JavaScript to create references. And with those references, we can perform different operations on those elements. But here's something very important to remember. On a web page, we can use the same class or multiple elements, but an ID must be unique. In other words, if we assign an ID to one element, we cannot reuse that same ID for another element. This is a rule you should always keep in mind. Alright, now let's see how we can capture an element using getElementById. In our index.html file, you will notice an input field with the ID amount. This is basically the ID for our amount input field. Let's now select it using JavaScript. For this, we write const input_field and then assign it like this: document.getElementById in the bracket amount. Now, if we print the input_field variable in the console, you will see that the amount element shows up directly in the console. But notice carefully, this isn't plain text. It's an actual HTML element. If it were plain text, it wouldn't appear with those colorful highlights. What you are seeing is the actual HTML element itself. In the same way, we can use getElementById to create a reference for any HTML element and then work with it. Let's look at another example. In our index.html file, you will see an h1 element with the text expense tracker and a class name title. Since it doesn't yet have an ID attribute, let's assign one. So we give the h1 element an ID like this. ID is equal to expense_tracker. Got it? That means now we can use this expense_tracker ID to create a reference to that element. If we go back to our script.js file and replace the ID amount inside document.getElementById with expense_tracker, save the file and then check the browser console. You'll notice that our h1 element shows up there. Alright, now let's take it a step further. Instead of using console.log, we will define a variable like this. Const header element is equal to document.getElementById in the bracket expense_tracker. I hope this part is crystal clear. Next, we want to use the header element reference to change the text of our h1 element. Currently, it says expense tracker. To modify that, we will use header element.textContent. This is a property of the header element, and through it, we can change the text inside the element. So we write header element.textContent is equal to expense tracker application. With this small change, we have simply added the word application to the existing text. Now save the file and check your browser. You will see that the h1 element has been updated. Amazing, right? Pretty fun stuff. Alright, let's explore something new. Just like text content, there's another very similar property called inner text. Both of them practically do the same thing. If we test it out by replacing our existing header element.textContent with header element.innerText, then save the file and reload the browser, you will see the exact same output. But there's a difference between the two. Let's try something. We will print both of them in the console side by side. First, write console.log in the bracket header element.textContent and then write console.log header element.innerText. Now save the file and check the browser console. Notice carefully. You will see a slight difference in the outputs. The inner text result shows everything in the uppercase or capital letters, while text content shows the text exactly as it's written inside the index.html file. So what's the distinction? Inner text prints the text the way it's rendered in the browser, whereas text content prints the text exactly the way it's written in the HTML file. Hopefully that clears things up. Alright, here's another little thing. The properties text content and inner text only give us the actual text, not the HTML itself. But what if you want to access the HTML? That's very simple. Just write console.log in the bracket header element.innerHTML. And there you go. Now the console shows you the full HTML content. Easy to remember. Now let's move on to another interesting topic, styling. Remember what I mentioned earlier? The reference we got for header element, what type is it? It's an object. And as we know, objects come with different properties and methods. We have already seen some properties like text content, inner HTML, inner text. Just like the properties we have already explored, there's also a property for styling elements. It's called the style property. If we want to apply CSS styles directly to an element, we can do it using this style property. For example, suppose we want to style our header element. Let's say we want the header text color to turn red. We can do that like this. Header element.style.color is equal to red. After saving, if you check the browser, you will see the header text has turned red. Pretty cool, right? Here, style is a property of header element, and header element.style itself is an object. Inside this object, you will find properties like color, font size, padding, margin, border, and many more. Basically, anything you normally write in CSS is available as properties within this style object. But there's one thing you need to keep in mind. We are writing JavaScript, right? And the syntax of JavaScript is different from CSS. That means when applying styles, some CSS property names have to be written differently in JavaScript. For example, in CSS, we write font-size with a hyphen. But in JavaScript, we can't use a hyphen. Instead, we write it in camel case. So, font-size becomes font S capital letter, then IZE. The rule is simple. Whenever there's a hyphen, remove it and capitalize the next letter. So, font size becomes font S capital letter and IZE. Background hyphen color becomes background C capital letter OLOR. Padding hyphen bottom becomes padding B in capital letter and the remaining, and so on. Let's implement this. First, we write header element.style.font-size is equal to 30 pixel to set the font size to 30 pixel. Next, we give it a background color. Header element.style.background color is equal to chocolate. That applies a chocolate colored background. Now save the file and check the browser. You will see that the font size has increased and the background has turned chocolate. But notice, if you mistakenly write header element.style.background hyphen color instead of background color, then after saving, the background color won't work. In fact, the console will even throw an error. And here's another thing. If you select the header element using Chrome DevTools element selector and look at the code, you will notice that the font size and background color styles you applied are injected directly as inline styles in the HTML. Remember this. Whenever we style using the style property in JavaScript, those styles are always added as inline styles inside the HTML. I hope you got the idea by now. For practice, you can try applying different CSS styles on your own. So far, we have seen how to manipulate the DOM using an elements ID. Now let's see how we can do the same with classes. In JavaScript, there's another method similar to document.getElementById, and that is document.getElementsByClassName. Notice the difference here. Earlier, it was getElement, singular, meaning just one element. But in the case of classes, it's getElements, plural. As I mentioned earlier, a web page can have multiple elements with the same class, but an ID must always be unique. That's why when we use getElementsByClassName to select elements by class, we don't just get one element. We get a collection, kind of like an array. This is exactly why the method name uses the plural form, getElements. Let's see this in practice. If you look at our index.html file, you will notice there are plenty of classes that have been used multiple times. For example, the class label is used several times. Then we also have classes like form group, transaction item, and so on. Suppose we want to target all the elements with the class name label. In our script.js file, we can write inside console.log document.getElementsByClassName in the bracket label. Now save the file and check the console. Notice what we get. It's an array-like list of all the elements with the class label. And what's the type of this array? It's an HTML collection. That means each item inside the HTML collection is one of the elements that has the label class. We can also select a specific element from this HTML collection using its index. For example, document.getElementsByClassName in the bracket label and then square brackets 0. Here we are grabbing the element at index 0, and if you check the console, you will see the very first element with the label class printed. In the same way, we can target other classes as well. For instance, in our index.html, we saw a class named transaction_item. If we replace label with that and write console.log document.getElementsByClassName in the bracket transaction-item, then in the console, you will see all the elements with the transaction-item class grouped inside an HTML collection. In the last lesson, we saw how to loop over an HTML collection, right? So today, let's loop through all the transaction-item elements and apply some simple styling to each of them. First, let's remove the console.log and instead we will write a for loop. But before that, we will store the transaction-item collection inside a variable. For that, we write const items is equal to document.getElementsByClassName in the bracket transaction-item. So now all of our elements are stored inside items. Next, we will run a for loop. For that, we write for let I is equal to 0, I less than items.length, I plus plus. This means the loop will keep running as long as I is less than items.length. And since items is a collection, items.length tells us how many elements are inside it. Pretty basic JavaScript, right? Inside the loop, we write items I dot style dot background color is equal to red. Here items I refers to the element at the ith index of the collection. On each iteration, the value of I increased by 1 and we apply styling to one element at a time, setting its background color to red. Simple. Now save the file and check the browser. You will see that all the items in the transaction history section have turned red. But of course, you can customize it however you like. For example, let's say we want odd indexed items to have a red background and even indexed items to have a green background. That's easy to do with a ternary operator. Inside the loop, we can write if I modulus 2 equals 0, then set the color to green. Otherwise, set it to red. In other words, on each iteration, the value of I will be divided by 2, and if the remainder is 0, we apply green, else we apply red. And don't worry, if you are not comfortable with the ternary operator, you can always use a normal if-else block as well. That works just as well. It's just a modern JavaScript shortcut syntax. Now save the file and check the browser. You will see the colors alternating. One green, then red, then green again. In other words, the colors are being set according to odd and even indexes. So today we covered quite a lot. Inner text, text content, inner HTML, getElementById, and getElementsByClassName. Now let's look one more thing. getElementsByTagName. From the name, it's pretty clear that the method gives us a collection of elements based on their tag name. And what are tag names? If we look at our index.html, we can see tags like div, img, h1, h3, and so on. Suppose we want to work with all the image tags on this page. Very simple. We can write document.getElementsByTagName in the bracket img. Let's put this entire expression inside a console.log and see the result. Alright, now if we save and run, notice something. Our page has exactly two img tags. One is at the very top in the header and the other one is at the very bottom in the footer. If we open index.html and search manually, we will find those two img tags. One in the header and the other in the footer. But here's something to note. The header image tag doesn't have any class, while the footer image tag has a class named footer-logo. Now look at the HTML collection we got in the browser console. Inside that collection, you will see the img elements listed, and for the second one, it shows img.footer-logo. That's basically an identifier. Think about it. You could have dozens of elements. So how do you recognize them individually? That's why class names are also displayed alongside, making it easier to identify elements uniquely. I hope that makes sense. Now let's talk about the most important methods, querySelector and querySelectorAll. These two are extremely powerful because they let us select elements just like CSS selectors. In fact, querySelector and querySelectorAll are like the combined version of getElementById, getElementsByClassName, and getElementsByTagName. Let's try them out. Suppose in our index.html file, we want to select the elements with the class label using querySelector. For that, we write console.log in the bracket document.querySelector again in the bracket dot label. Notice here, we are passing dot label inside, just like we do in CSS. With getElementsByClassName, we only passed label, but with querySelector or querySelectorAll, we use dot label, exactly the way we define styles in CSS. Now save and run. You will see that it only gives us one element. But wait, we know there are multiple elements with the class label, right? That's correct. querySelector always returns only the first element it finds with that selector. This is very important to remember. And if you want all the elements with that class, then you will need to use querySelectorAll. Alright, let's copy that console.log line and paste it on the next line. Now replace querySelector with querySelectorAll. If you save and check in the browser console, you will see two outputs. The first output is just a single element because that came from querySelector. The second one from querySelectorAll is a node list that contains all the elements with the class label. Here's something to note carefully. querySelectorAll always returns a node list, while getElementsByClassName or getElementsByTagName return an HTML collection. These two might look similar to arrays, but they are actually different data structures. As we saw in an earlier lesson, we can't use the forEach function directly on an HTML collection, but with a node list, you can easily use forEach without any issues. Keep these subtle differences in mind. Alright, now let's move on and see how to query by ID using querySelector. Just like I mentioned earlier, we will write the selector exactly the same way we do in CSS. In our index.html file, under the Add New Transaction section, there are some form fields. Among them, I have set the ID amount for the amount field. And for the date field, the ID is date. And intentionally, I have also used the same ID amount again for the category field. Earlier I mentioned that by convention, an ID should only appear once on a page. But technically, if you use querySelectorAll, you can still select multiple elements even if they share the same ID. Let's try that out. Instead of label, let's pass hash amount in the querySelector and querySelectorAll. Why the hash? Because in CSS, whenever we target an ID, we use the hash sign. The same rule applies here. For classes, we use a dot, and for IDs, we use a hash. Now save and check the browser console. You will see that querySelector gives us the very first element with the ID amount, but querySelectorAll returns a node list containing all the elements that have the ID, even though it's not standard practice to reuse an ID. And this is something you will never get with getElementById. That's why I said earlier, querySelector and querySelectorAll are extremely powerful methods. You can also use querySelector and querySelectorAll to grab elements by their tag names. For example, instead of hash amount, if we write just A, we will be targeting all the anchor tags on the page. With querySelector, only the very first anchor tag gets printed in the browser console. With querySelectorAll, we get all of them. Now let's wrap up this lesson with one more powerful feature. For this, let's go back to our dot level example. So instead of A, we will write dot level. Check the console. You will see the same output as before. Here's where it gets interesting. Just like in CSS, we can use pseudo classes to style specific child or sibling elements. Remember how we do it in CSS? We take the element we want to target, then add a colon, followed by nth child, and inside the parenthesis, we specify which child we want to style. Exactly the same concept applies here too. In the same way, if we write dot level colon nth hyphen child and in the bracket 3 inside querySelector, then save the file, you will see that querySelector gives us only the third child element. With querySelectorAll, we still get a node list, but it contains just that single element. Pretty interesting, right? That's how powerful this method is, and you can even do more advanced things with it. For example, when improving websites' accessibility, we often use attributes like ARIA or data. You might not be very familiar with this at this stage, but let me give you an example. In our index.html, there's an add transaction button. If you check, you will notice that it has a role attribute with the value button. Now, this role attribute isn't something you will see directly in the browser view. It's there to improve accessibility. It helps assistive technologies like screen readers understand that this element is a button. Of course, there can be many other attributes like this. I am just using role as an example here. But the point is, you can use querySelector or querySelectorAll to target any attribute in exactly the same way. Alright, Now let's remove the label colon nth child part. First, we'll put a single quotation, okay? Inside that, right at the beginning, we will use square brackets. This is the convention. And yes, you can do the exact same thing in CSS too. Inside the square brackets, we write the attribute exactly the way it appears in the HTML. In our case, its role is equal to button. So we place that inside the brackets, just like this. Now save the file and check the browser. You will see we have successfully selected the element with role is equal to button. If there were multiple elements with that same role, then querySelectorAll would return all of them in a node list. And that's how you can target any attribute on the page and perform whatever operations you want on it. In the next lesson, we will explore some even more interesting operations. And if you would like to dive into more advanced topics like set attribute, remove attribute, and other kinds of DOM manipulation, along with extra practice, you can check out the DOM manipulation cheat sheet I have posted on our logicBase Labs page. Go through it, try things out, and practice as much as you can. If you run into any problem or get stuck, feel free to mention our logicBase Labs page in a public post, and we will do our best to help you out. I will also leave the link to the cheat sheet in the video description. Oh, and please don't forget to follow the logicBase Labs page for more valuable resources like this. See you in the next one.